Okay, hello guys. Today I'll do the review for the final exam of the control system. So I think it's really easy, so I do very quick review about that. Okay, so we have few section like let me check that. So we have block, time constant, theorem, Routh, Locus, Bode, diagram, stability. It's okay. So we have about 6-7 sections. So I will do one example each. I think that is enough because the exam is not hard. I think so. Okay. So for the first one is the first order system. Okay. First order system. Okay. So the example is 4.1. Yeah, you can check it in the book. Oh no, 4.2. Okay. So we have 8 over s plus 8, and then the output. It's really simple. This step input. Okay. So the question is find the time constant. Time constant stall is just equal 1 over 8. Yeah, second. So 1 over 8 is 0.125 seconds. Oh, it's easy. Right time is 2.2 tau. So take 2.2 multiply with this one. I have 0.275 seconds. Yeah, and the settling time TS, I think I don't remember the formula of that, so wait, let me check it. Yeah, 4 times tau. So 4 tau. So we have 4 multiplied with 0.152 125 is 15 seconds. So yeah, so we done the first one, the first order system, find the time constant and so on. So this easy. Okay, let me move to the next one. The next one is the second order system. Okay, second order. Let me find an example for that one. But it should be good. It should be good. So 13. So second order system. Okay. The example I took is 13 4.13a. Okay. So we have t sub s equals 16 over s squared plus 3s plus 16. Okay, that one. So it's like they just the open loop, so you don't need to close that loop. So we have that, and they ask for zeta omega n ts tp and percent os. I'm not doing the right time because the right time needs the table. I don't have that table here, so, and I don't think professor will ask about that, so I don't need that. Okay, so we have this. So what we will do with this one? The first one, if you see the second order system, you see s squared s and s power 0 is 1 here. So you do this one. 16 actually equal to omega n squared. So omega n is square root of that is equal to 4. Okay. So next we have 3. 3 equal to 2 zeta multiplied with omega n. Right here. So we have zeta equal 3 over 2 omega n. And we have omega n equal to 4 right here. So we just substitute in. So 2 multiplied by 4. So just use calculator for that. 0.375. So we have zeta equal that. We have omega n. We done. So right now, okay, we need TS. What is TS? Is settling time. So TS. What is the formula for settling time? I think, let me check, I don't remember. So if you don't remember anything, just write down in the cheat sheet. Yeah, 4. Okay. So we have 4 over zeta omega n. This is the formula for settling time. So 4 zeta is 0.375 multiplied with 4. So with the calculator, 1 over 0.375. 2.67 second. Okay. So the settling time done. The peak time, TP, is equal, that one I remember, pi omega n square root of 1 minus zeta square. This is zeta. My zeta is look like the F, but actually zeta. So pi omega n equal 4 square root of 1 minus 0.375 square. Yeah. So we have pi 4 1 minus 0.375 square. 0.85 second. Yay. Okay. And now we find percentage overshoot. The formula of this one is e to the negative pi zeta over square root of 1 minus zeta square and multiply for 100 because it's percent. Okay. So e, oh, what? E negative pi times 0.375 square root of 1 0.375 square. So 28% overshoot. 28%. Okay. Yeah, so we're done with this one. We're done with the second order system. Just that one. So, okay. The next topic is the final value theorem. Okay. This one is actually really easy. So final value theorem. Final value theorem. I take the example exactly like this one. So we have the step input to the system like this one. Yeah, this is I just take the example for that and then the output. So the question asks you phi c of infinity or phi c of t when t go to infinity. So how you find this one? The first step is you do Laplace, so do everything transfer function, something like that. But the final value theorem, we use that one. So c at infinity is equal to limit s go to 0 at g sub s. Oh, actually c sub s. Yes, c sub s. C is here, right? And what is the c? It's actually 1 over s multiplied with the transfer function here. 16 over s squared plus 3s plus 16. Right? Right here. So, okay, just substitute in. We have limit s go to 0 s over s times 16 s squared plus 3s plus 16. Okay, so s here cancel out. So actually you just block 0 to s here. So what do you have? C infinity equal 16 is an 0 plus 3 times 0 is 0 plus 16. So you have 1. Yeah, it's faster. Final value theorem. Okay. Let's set another system. Yeah. That one. Okay. So we done that. What we have next is the block. The block. Okay. Okay. Block. I like block diagram. So I'll do the block here. I think the block is chapter 5, something like that. Okay, the block chapter 5. I'll find something easy, I do. But okay, I'll do this one. That one interesting. Five 12. Okay, 5 12. Okay. Okay. Block. The question I do is 5.12. Chapter 5, question 12. Okay. So I will draw it here for you to see. So we have r sub s. Oh my gosh. This one plus. No. It's too much. Let me do it here. Okay, right here. R sub s is plus, is minus. Okay. This is 10. Okay. Right here. This is also 10. Okay. And then this is the plus. This also the plus. Yeah, okay. And then it go to 1 over s plus 2. Okay. Let's go to 20 over s. Oh my gosh. Okay, let's go to c sub s. Okay, and then we need to feedback it back here, right here. Okay. Oh, and then we have one more. We have one more feedback, 0.2. Yes, here. Okay. This is minus. Okay, so it's plus minus, plus minus. So it's a mess. Oh my gosh. Okay, I'll do it step by step for you to see. So my suggestion is you do the simple one first. Okay, what is the simple? This one. This one is simple. Okay, right here, really simple. So I'm not redraw it. I just eraser and do it here. Okay, I don't have the tablet, so I have to do that way. So if you have two blocks next to each other like that, you just multiply them. Okay, 20s. So you do multiply 20 over s. Yay. Okay, so you combine one block like that. Okay, what's next? So you see plus and minus. You see that? Plus and minus. So you can split it up like that. So you have plus and minus. To that block, you can split it to a plus here, the plus here, and then the plus here and the minus here. Yeah, you can split it into that way. It's the same. So 3 input, 1 output, right? Plus and minus, like that. It's valid. So I can do that. I split it into 2. So this one is plus, this one is plus, and then right here is plus, and the minus. Okay, so it's more simpler. It's more simple. So we have right now here. Make sure you guys can see it. Okay. So it's simple right now, right? So this way, plus, so you can add up 10 plus 10 plus right here. It's not a feedback. The feedback is go that way. This is just the forward. So you just add them. 10 plus 10 is 20. So I get rid of this. Get rid of that. And I have 20 here. Okay. Yay, so we have that. We done that. Let's multiply. Okay. We done. We have that one. Move to this one. This one is the feedback. The feedback, you have that. So I redraw that one here. Plus, minus. So this is G sub S. I just call it G sub S. This is C sub S. And you have feedback is H sub S. That. So the total transfer function of this one, T sub S, is actually G sub S over 1 plus G sub S and multiply with H sub S. Like that. Same thing here. You can do the same thing here. Okay, I redraw it. It's ugly right now. Okay, I redraw it here. Okay, R sub S, still plus, still minus. The unity, keep it the same. Okay, this 20, keep it the same. And that one right here, I do the same with this one. So I have the transfer from the new one, which is G sub S, is that. So it's 1 over S plus 2 multiply with 20 over S. And then divide by 1 plus G sub S is that one again. Oh my god. Okay, 20 over S, S plus 2. I do that. And then multiply with 0.2S. 2s. Okay, that one, yeah, something like that. This is C sub s. And the feedback again. Oh my gosh. Okay. Okay. 20 in series with this one. So multiply. Okay, multiply with the big one here. Oh. So 20 multiply with all the big one. Yeah, I think from that one you can do it. So I have this. You guys can simplify, but I'm lazy, so I'm not doing that. So I call this one chi sub s. Okay, I call this one chi sub s. So the transfer function, the total transfer function is chi sub s 1 plus chi sub s, because right here is unity feedback. Okay. Okay, so after I do all the simplification, I have rs here, go to t sub s and go to c sub s. Yeah, this is the final answer. T sub s is that, chi sub s is that. You just plug in and do all the simplification, and you got that. Okay. Okay, so hopefully I do it correct. Okay, yeah, so I'm done with the block diagram. Okay, block, time constant, final value theorem. Okay, root locus. Oh, root locus easy. I just did it in the midterm. So you just review the midterm and you should be good. But I will do the one example, only one, not the design. Okay, root locus. Root locus. Okay, so I have chi sub s like that. Chi sub s. This is the one I make it up. I'm not. Yeah, I don't know. I don't know. I should be follow the book. Okay, let me wait for me a little bit. The root locus question in the book is boring, bro. Okay, I make it up. So s what? S plus 10, and then s plus 2, s plus 3, and s plus j, and s minus j. Okay, it's boring. Okay, so how to draw that? I show you how to draw it, this one, but in the exam it's actually professor will provide you 5 figure and you have to choose which one is the root locus of chi sub s. So right now I show you how to draw it, but yeah, okay, so how to draw that? So we have 1 0 at -10, right? So at -10 over there we have 1 0 at -10. See, you have opponent -2, -2, -3, right? -2, -2 here, -3 here, this one minus j and plus j, so it is the pair of conjugate. So okay, plus j here minus j here. Okay, so how you draw that root locus of that one? Okay, I show you. I may do wrong, but okay, I try to do it correct. Okay, the first one you see in the real axis. Okay, this is real, this is imaginary axis. So in the real axis, you pick a point, random, you pick random here, and you look into the right. Okay, you pick a point and you look into the right. If you didn't see any obstacle, I don't know, if you don't see anything in the right, so it's not a root locus, it's not in the root locus. Okay, so I do one more example. So you pick a point here, you look into the right right here, you see one obstacle, right? So one pole, just in the real axis you see one pole. So you can conclude right here to right here is in the root locus. Okay, okay, show you. And if you see the odd number of obstacle, odd number like 1, 3, 5, 7 something, so it's in the root locus. If you see even number like 0, 2, 4, 6, it's not in the root locus. Okay, so example right here, look into the right, you see 1, 2, just in the real axis, 1, 2. So right here, so from here to here, it's not in the root locus of that one, because 2 is the even number. You got that? Okay, so right here, no, from here to all the way, so you have 1, 2, 3. 3 is odd, so yes, we have root locus here. Okay, yeah, this is the first one. The first one is check the root locus in the real axis, so we done that. The second one is to find the asymptote. The asymptote is 2n plus 1 times 180 over the number of 0, 1, 2, 3, 4, minus the number of pole, minus 1. So you have, so n is any integer. You block any integer here. Okay, block any integer right here, and then you find the asymptote theta. If the theta is in negative 180 to 180, you take it. Okay, okay, yeah, make sure I'm still recording. 2n plus 1, 180, 180 over 4 minus 1 is 3. So 60 is in here, so it's okay. 0, 1. If it 1 is 180, so it's good. So 180. Okay. Negative 1, so negative 1, negative 60. So still in here, still good. Negative 60. Negative 2 is negative 180 is 180 is the same. So we have 3 lines like that. Okay. And then Okay, and then you find the centroid. The centroid is, you add them. So if we add on the pole and you minus 4 on the 0, you have -2 minus 3 minus j plus j, right? Minus 10 over 4 minus 1. Okay, so j, you don't have that. -3 minus 10 over 4 minus 1. So -5. -5. So you right here, you take -5 right here. So from here to here. Okay. And then you draw 60 degree. 60 degree like that. Yeah, I just do it. So I just assume this one 60 degree. Okay. But it's not, I think it's just 30 something. Okay. So I assume this one -60 degree. Okay. We have that. Okay, what next? Oh my gosh, I take the question too hard. Okay. The pole near the 0 is absorbed by them, so we have something like that. Something like that. Okay. Let's go here, let's go here. Go to the 0, go to the 0. Absorbed by the 0 here and absorbed by the 0 in infinity. So we have 1 0 here, 1 0 infinity, and then we need 2 more 0 at infinity to absorb the 2 pole. So the asymptote right here. This one go with the asymptote. This one. That one. Yeah. So I think the root locus of that one is something like that. Am I still recording? Oh yeah. Yeah. I think so. But I don't know. I should check with MATLAB, but something like that. I will do one more easier. So I have, oh yeah, in the midterm we have that one. We have that one. This one, pole, 0, pole. Okay. And the question asked is, this root locus, oh, it should connect. Yeah. Is it valid for root locus? And few of my friend do it not correct. So the way it correct is from here to here. Okay, I do it again right here. So x, x. Okay, from here to here. No, here to here. Yes. Okay, here to here. Yes. Here to here. No. Here to here. Yes. You see, it's different. And then you have to calculate for the centroid and asymptote. Okay, I just assume. Okay, I just assume the centroid something here. I don't know. The centroid something here. The asymptote actually 90 and minus 90, but the centroid I don't know. So I just assume here. So the root locus of that one should be like that. Yeah, something like that. Okay, not that one. That one not valid. This one valid. Okay, so we done the root locus. So if you see the root locus, just check for the pole and 0, and check for the how can I say it? Is it the same on the here and here? Is it the same? Oh my god, I forgot the word. Yeah. Okay. Yeah. So we done root locus. Then let me see anything else. Bode diagram and stability. Okay, Bode diagram and stability. So I do Bode diagram first. Bode diagram to find a phase marching and gain marching. It's actually really easy. I think I have. Yeah, I have it here. Okay, this is my practice problem, and I found this one is really good for you guys to understand how to do it. Okay, so okay, I have the body plot like that. So the body plot like that. Body plot. Okay, and the question professor will ask you to find gain, margin, and phase margin. Okay, these two. Yeah, just these two. In the final exam, he just give you the body plot and ask for these two. Okay, so how to do it? Okay, how to do it? For the gain margin. Wait, let me check it. Okay, anything you don't remember, you have to write it down in the cheat sheet. Okay, the gain margin at the phase equal plus or minus 180. The gain margin is 1 over the Q, the magnitude of it. Okay, I show you how to do it an easy way. In the body plot, so at the phase at 180 or negative 180, so right here, you're looking for the phase 180 right here. You so it's right here. You see it? So from that, you use the ruler to connect the phase and the magnitude plot. So you connect them. Okay, you connect them. And this one cut the bond right here. Okay, you see that? Cut the bond right here. So the gain margin is this one, from 0 to the cut. See, from 0 to the cut. So the gain margin actually 0 and 20, so it's just 20 dB. So gain margin equals 20 dB. So it's easy, just 180. Draw a line, cut the magnitude here, and then you measure from 0 to the cut, and then you have the gain margin. Just that. Easy. So for the phase margin, how you do it? Phase margin is different, so you find from this and you draw the line to this. Okay, so the phase margin, I'll show you here, is at the magnitude equal to 1. You see, the magnitude equal to 1, or the magnitude of J omega at dB equal to 0. Okay, at dB equal to 0, because 20 log 1 is 0. So at 0, okay, this one in dB, this one in dB. So 0 right here, you see that? Then you draw a line. You cut the phase plot right here. Okay, and then the phase margin is from 180 to the cut, so from here to here. So this one is the phase margin, that one. So how you calculate for that? You estimate them, or you estimate it. So 180 to 135 is 45 degrees. So this one from here to here is 45 degrees. So 45 plus a little bit here. So let me estimate 135 minus 90 equal 45. So this one is 45. This one is about 1/3 of them. 1/3 of this one. So minus 3 is 15. So 15. This one is 15. And this one is 45. So the phase margin is 60 degrees. Yeah, just estimate them. Okay. So the gain margin from -80 go to the gain. So and measure from 0 dB to the this one. You got 20. And then for the phase margin go to 0 in the cut and measure from 180 to that one. Okay, it's easy. Okay, so we're done with the body diagram, phase margin, gain margin. Yay. Okay, make sure I'm still recording. Okay, I'm still recording. Okay, the last one is the stability. Yay, my favorite. Stability. Okay. So, stability. And professor say using Routh table, okay? Okay, stability using Routh table. So, okay, I show you how to do the Routh table. Let me find the example in my note. I think we have a really good example. Okay. Okay, so we have T sub S here equal 10. This is at power 5. What? Power 5? Okay. Plus 7S4 plus 6S3 plus 42S squared plus AS plus 56. Okay, so we have the transfer function, that one, and you want to know, is it stable or not? Okay, is it stable or not? So the Routh table. Table. So how you do the Routh table? You do like that. S5, S4, S3, 2, 1, 0. Okay. So right now I do that. I'll do this one later. Okay. And from the 5, you do like that. Right here is 1. And then you jump 1 to here. So 6. And then you jump again to 8. Okay. And then you jump again is 0. So we never don't care about that. And then next S4 right here 7. Jump 42. Jump 56. Okay. Okay, you have that. And then how you calculate for S3? You do this way. Let me draw it a little bit. So 1, 6, 8, 7, 42, 56. Okay, so right here you take that one, you always use the first column. 1 multiply with this one minus this one multiply with that one. So 1 multiply with 42 minus 7 multiply with 6, and all divide for negative 7. Okay, this is positive, so you divide for negative 7. Yeah, something like that. And this one, how you calculate for that one, you do still use the first column, but now with the third column here. So 1 plus 1 multiply with 56 minus 7 multiply with 8, and then you still divide for negative 7. Okay, so what do you have? This one 0. Okay, it's interesting. It's 0, so it's 0. Okay, I just equal to 0. Oh, it's 0. Okay, and that one still 0, because we use this one 0. I told you here, right? 1 0 minus 0, so right here 0. Okay, so we have all 0 at S3. Yeah, we have all 0 at S3. So how you do that? Okay, if you have one row had the value at all 0, you go back to the previous row. So now S power 3, you go to S4. Okay, so you go to S4, you have PS equal to 7 S4 plus 42 S square plus 56. Right? 42 S square plus 56. We have that one. And then you do derivative. You derivative of that. So PS derivative is 7 times 40, 28 S cube plus 84 S plus 0. Okay, so right now you do that. Not 0, not 0, not 0, but S3, you see S3 28 84 and then 0. Okay, got that? Okay, and then you do S2 S square, do the same. This one multiply this one minus this one multiply that one, and now divide it for negative 28. Okay, let me do it. Okay, I do calculation for the fast. 84 minus 28 multiply with 42 and divided by negative 28, which is 21. Right here 21. Okay, 7 times 0, do the same. 7 times 0 minus 28 times 56 and divide it for negative 28. Minus 28 times 56 and divided by negative 28. 56 right here. And S power 1. This one 0. You don't have to do that. So right here 28 multiplied with 56 minus 21 multiplied with 84 and over negative 21. We have 9.3. Okay, and then this one 0, this one 0. Okay, so it's 0. So S0, the last one. So 21 multiplied with 0 minus 9.3 multiplied with 56 and minus 9.3 56 right here. So from that one you can say this one positive positive 28. Positive, positive, positive. So there's no change in sign, right? So this one stable. Got that? So if you have negative 9.3 here, so you have positive, 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 but if negative, so one change and one change. So they have two root in the right half plane, so it's not stable, right? Okay, so it's stable. Okay, so I think this example is hard. I'll find one more easy one for you guys. I think to 5K or something like that. Professor like that. 5K. So I have one more example about root table. T sub s equal k s cubed plus 3s squared plus 2s plus k. Okay, k. Professor like k. Okay, how you do that? The same. S cubed s squared. Okay, s cubed 1 jump 2 jump 0. Okay, never mind. 3 jump k. Okay, get that? And then s power 1. This one multiply with this one is k, minus this one multiply with that one is minus 6, and divide it by negative 3. Negative 3. Okay, and that one multiplied by 0 is 0, minus this one multiplied by 0 is 0, so this one's still 0. Okay, you don't have to calculate for that. So s0, that one multiply 0 is 0, minus for this one multiplied by that one, minus this one is 6 minus k over 3 multiplied by k, and all divided by k. Wait, I think I do wrong. Let me do it again. Okay, that one. This one multiplied with that one minus that one. Okay, minus that one is minus 6 minus k over 3 multiplied by k, and divided for negative of this one. So negative of this one is 6 minus k divided by 3. Okay? You get that, right? I feel like I do something not correct. Oh, minus for that, sorry. So I have that. Okay. Let me do it again for clarification. Right here is 6 minus k over 3. Okay. Okay. So 3, this one, that one multiplied minus this one multiplied with this one. So minus k and 6 minus k over 3. And divide it minus that one. Yeah, correct. So everything minus 6 minus k over 3. So 0. So you can see minus 6 minus k over 3, and this one minus 6 minus k over 3, so that one over cancel out. So we still have only k for that. Okay, right? K. This one 1 3 6 minus k over 3 in k. So the question actually is find k for stable system, right? Okay, so in order the two system to be stable, you have no change in sign, right? So right here, positive 1, positive 3, so we need 6 minus k over 3 need to be positive. So 6 minus k over 3 need to be positive. Got that? And then k. So k need to be positive. k need to be positive. So we have these two conditions. Okay, so if you do for that, you will have 6 minus k larger than 0. K larger than 0. So you have 6 larger than k and k larger than 0. And all of this, you have 0 need to larger than k larger than 6. Okay. Actually, it can be equal. Yeah. Because if it's equal, I don't know. I don't know is it equal or not, but it's actually neat. Okay, just let that. Professor will give you the K and you just plug 6 on it and you good. Okay. So here is the answer of that one. Okay. No change in sign. Okay, so we have block, time constant, second order system, final value theorem, Routh locus, Bode diagram, and stability. Okay, so yeah, it's pretty much all of the final. Yeah, all the question in the final. So I review here, and actually for me to remember. Okay, so I finished my review, so you guys can watch it and maybe review yourself. Okay, yeah, so thank you for watching and good luck for your final. Bye bye.